DC sputtering. Two-dimensional nanomaterials like thin films, thin coatings, thin layers can be deposited using this technique, that is DC sputtering. It consists of a vacuum chamber, a substrate holder, substrate, and a target mounted at the top of the vacuum chamber. A freon or argon gas, inert gas, is allowed to pass through this inlet. When high potential is applied between the electrodes, ionization takes place inside the vacuum chamber. The ionized, positively ionized high energetic ions accelerated towards the target and bombard the target with very high energy. Therefore, the atoms from the target are dislodged from the target, and due to their own weight or mass, they descend towards the substrate and deposited as a thin film on the substrate surface. This is a simple physical method which is based on the momentum transfer between the positively charged high energetic ions and the target atoms. Advantages of this method: as the atoms of the coating material are dislodged from the target simply by a physical momentum exchange process, any material can be coated using this technique. Multi-layered coatings can be obtained by operating several different material targets sequentially. Gases like oxygen and nitrogen can be introduced into the chamber to achieve reactive sputtering. Thin films with a high purity and a perfect surface finish can be obtained using this method. Limitations: high initial cost is required and it requires very high vacuum. Applications of sputter deposition technique: this method can be used for the fabrication of transparent conducting electrodes like tin oxide, zinc oxide, indium oxide, zirconium oxide, etc. Reflective and anti-reflective coatings can be fabricated using this technique. Thin film resistors and capacitors and some other electronic devices can be prepared using this technique. Luminescent films for display devices, piezoelectric layers, optically addressed memory devices can be prepared using this technique.